Okay, I'd like to tell you about graphing equations. The AP tests like to do stuff like this. They make use of the fact that for a straight line, y equals mx plus b. So this is one of the equations for a straight line on a graph. Y equals mx plus b. So if you have y and x, then you might get something like that, and this is the y-intercept at b. If you put in 0 for this term, this goes to 0, so that's b. And then this is the slope. The slope is m, and so that's what that is. Okay? I mean, that's just something that I'm sure you learned maybe in grade school. Okay? So this is what the AP committee likes to do then. They'll take an equation like let's say a car has constant acceleration and it starts from rest. So, and if it starts from rest, then that means this term goes away because V0 is 0. And so they might give you the graph. They might give you some data for X and for T. And you need to know that if you want to get a straight line graph, this is what they can ask you to do. If you graph x versus t squared, so you square the times that they give you in a column, then and you graph that, you're going to get a straight line. It's going to look like that. And so let's see, if y equals mx plus b, and you have this equation, x equals 1/2 a t squared. You see how this is y? And you see how this is x? This is the x. There is no b. This is plus 0. So b, this is 0. And so this is the slope. So the slope of your graph is 1/2 a. So the slope of graph, that's not equal to a. It's equals 1/2 a. Let's try another one. So let's say that instead they make use of this equation, v final squared equals v initial squared plus 2a delta x for something with constant acceleration. Okay, well, let me rearrange this in terms of the y equals mx plus b. So I want to put this in terms of y equals mx plus b. So that would be v final squared equals 2a delta x plus v0 squared. Okay, so if I were to graph v final squared and delta x, then what I would get is maybe something that look like that. And this would be v0 squared, and the slope of this thing would equal 2 times a, twice the acceleration. So we're taking our data. If they gave you a data table with say delta x and v, you would want to know, you would use that equation and hopefully see that if you square v and you plot v squared and x, if you plot these two columns, you'll get a straight line. Let's do another one. F net equals ma. So using this equation, so y equals mx plus b. Oh, this is slope, and that's mass. But so if I were to plot f net and acceleration, then the slope of this graph would be the mass, because y equals, so the slope, boy, this is a little tricky, the slope is equal to mass. And so yeah, so y equals m mx plus b. It's the 0 y-intercept. Let's try another one. What if you had the period of a pendulum, if you plotted the period of a pendulum versus the length of a pendulum, that's not going to be a straight line. But to make it a straight line, this is what I would really have to plot. Let's see, the period of a pendulum is 2 pi times the square root of L over G. That's for a simple pendulum. Let me square both sides, so T squared is equal to 4 pi squared times L over G. Oh, so I would want to plot T squared. See how y, this would be our y, equals mx plus b. Y equals mx plus b. So if I plot T squared versus L, then the slope of this graph, the slope of that graph is going to be equal to 4 pi squared over g. The slope of the graph is 4 pi squared over g. So they might give you this graph for a particular planet and ask what g is for this planet. What is the g on this planet? And it's up to you to realize that the slope of this graph is 4 pi squared over g. And then find the slope and solve for g. See how that works? Let's just keep on trying these. Kinetic energy. If I were going to plot kinetic energy and velocity, an object's kinetic energy and its velocity is a capital K. That's not going to give me a straight line. What will give me a straight line? Well, if I know that kinetic energy is 1/2 mv squared, then if I plot K versus V squared, then the slope, that slope is 1/2 times the mass. See, y equals the slope times x plus 0. Y equals mx plus b. Let's do another one. These are so fun. So let's go with, maybe we'll do some E&M. Okay, how about resistance and length of a wire? Or how about resistance and the area of a wire? How about that? The cross-sectional area of a wire. So we know, at least I hope you know, that that's equal to rho times L over A. So if I were to plot, say, resistance versus A, that's not going to get it done. That's not going to be a straight line. So you can't get the slope of a line that's not straight. It doesn't have a constant slope. So rather what I'll do is I'll rearrange this to look like this. This is the same thing as rho times L times 1 over A. So if I write that as R equals rho L times 1 over A, do you see how this is Y equals mx plus B? And so if I plot 1 over A, then I will get a straight line. And the slope of that graph will equal the resistivity times the length of the wire. So like if you know what the length of the wire is, then you can get the resistivity of the wire. Okay, let's go with 2 more. Capacitance. Let's say I know capacitance is epsilon naught A over D. And they do an experiment where they're plotting capacitance, how it varies with D. Well, if you plot that, you're not going to get a straight line, how capacitance varies with D. But if you instead make one more column, 1 over D, and you plot that, you will get a straight line. Because this is like capacitance is equal to epsilon naught A times 1 over D. Y equals mx plus B. And so sure enough, the slope of that graph will be epsilon naught times A then. That's what the slope of that graph is. Okay, and last one that I'll do, let's do an Ohm's law. If you were to plot, say, voltage and maybe current through a resistor, well, if the resistor is an ohmic resistor, then it's equal to I times R. And so this is like Y equals M. Well, let me rearrange this because this is my X. So Y is equal to MX plus B. And so, yeah, that's going to give me a straight line, and the slope of this graph, the slope is resistance. So they just do that quite a bit. And so just be ready for that. Okay, good luck. Bye.